This conference will now be recorded.
So today here for PD demo of physical design course. So which we are going to start from Monday, right? So first, what is the agenda of this demo class? What we'll see in this demo class, right? So in demo class we are going to see. So what is physical design? Right? Means what we understand from the term physical design or what we do in physical design, and we understand steps in physical design. Next is course curriculum. What is our course curriculum? Like what is the content of our course? What we cover in physical design. So next we are going to see about. Yes, any doubts you have? Right. Next we are going to see about class structure, like how your classes are going to be conducted, on what online mode or offline mode, how it is conducted, right? So class structure. So this is what we are going to see. This four things we are going to see in this physical design demo, and later your queries. If you have any queries, right? So we will see about that. Um, okay, if you are about to join, right? Before continuing with this physical design topic, like what is physical design, why we go for physical design, right? Before continuing with this, so I want to talk about only one thing. What is foundry? Foundry? Can you tell me what is foundry? See, foundry. See why our agenda, main agenda of this is to get IC fabricated, right? VLSI stands for what? Very large scale integrated circuit. So what is IC? IC is nothing but called IC is nothing but called as integrated circuit. So our main agenda to work in VLSI is we want the IC, right, integrated circuit to be fabricated, and it should be working. It should be having less area, and it should be working with highest speed, right? And it should be functionally good. That is what the main agenda. So when we want to fabricate or when we want to design an IC, so when we want to get an IC in the market, there are two things. One is fabrication, right? One is fabrication, another one is design. IC is fabricated and IC is what? Designed. See where this IC is fabricated. Where IC gets fabricated?
The foundry.
Yes, IC gets fabricated in foundry. The foundry is a place where IC is fabricated. So it is a place where IC is fabricated. So whether India has sophisticated foundry, right? We don't have sophisticated foundry in India, right? But few companies have foundries, and even our some of the prestigious universities and our ISRO has foundries. but they are not well sophisticated. It means they cannot fabricate the chips. Means good quantity of chips. I'm not telling about quality. I'm talking about what quantity. Means they want to produce minimum 10,000 chips per day. That is not possible in the foundries what is available now. So India doesn't have sophisticated foundry. Why? Because to implement a foundry, right, there is a huge requirement or huge investment required. So minimum more than 500 crores has to be invested to open one foundry, and foundry should be very neat, clean. It should be 100 times or 1,000 times cleaner than your ICU, right? So for that reason, opening foundry is not very easy. And who is going to work in foundries? More than the knowledge of electronics, there should be a knowledge of what? Chemical reaction. Electronics engineer has no much role in foundry. Chemical engineers has to be working in foundry. So there is a process called as IC fabrication. How IC fabrication happens? It is a process of oxidation. Oxidation means on top of vapor, they are going to put what? They are going to put the oxidation. They are going to put the some oxide gas on top of this. How this oxide gas reacts with semiconductor? So it should be known. So more than an electronics engineer, a person who is very good in chemical or chemical engineer who works in what? Foundry. So, but we electronics engineers work in what? We work in IC design. We are not going to work in IC fabrication, but we are working in what? IC design. But to work in IC design, we should be knowing how the fabrication happens. Not in depth, but at least we should be knowing what is a process. Right? So we all engineers work in what? IC design. We will not work in IC fabrication. So all the companies, whatever we are working now, like Intel or AMD or Qualcomm, everywhere we are working in IC design. So IC design happens by using what? IC design happens by using a computer. In the laptop only we are going to work. We are not going to do anything in the circuit board, right? So we use a EDA tools. What EDA stands for? Electronic Design Automation Tools. Nowadays, tools are very smarter than the human beings. With the evolution of the AI and other tools of software, tool will do most of the work. Tool will do most of the work, even in IC design also. So we use electronic design automation tools to design an IC. So you have already used your EDA tools in your UG classes. For example, you would have used your Xilinx. Xilinx is used to design what? FPGA or Vivado, right? That is used to design what? FPGA. So that is FPGA is different thing. That is a array based design. So we are working on cell based design. So our IC gets fabricated in what? Foundry. But FPGA is already an IC. FPGA is already an IC. It is given to you. Just you have to program that. You have to create the bit file and you have to dump on the FPGA. That's it. FPGA already IC is given to you. But here what happens? You are designing first, then you will give some file to the foundry. Foundry will fabricate IC for you. So then what you are going to pass design team, what they will pass to the foundry, so that foundry will fabricate IC to you. For example, the company Qualcomm, right? Their design is completed. IC design is completed by using what? EDA tools. But what they will give to foundry, so that foundry is going to fabricate IC for you. So design team is going to give what? They are going to give DDS file. DDS means what is DDS? Full form. Graphical data stream. So we are going to give this GDS file to the foundry. Foundry is going to fabricate IC for us. Then what is present in this GDS file? Ultimately, we have to generate what? GDS file. And this GDS file we have to give to what? Foundry. So based on the information present in GDS file, Foundry is going to fabricate IC for me. So in GDS file, what is present? So in GDS file, layout of cells are present. Layout of cells. Cells means it is what? Gates. Layout. So you know what is layout? You know what is layout? It's a top view of your what? Top view of your MOSFET. It's called as layout. So you know CMOS, right? What is CMOS? CMOS is PMOS and NMOS together is called as what? CMOS. This is your CMOS. This is your V in. This is V out. This is VDD. And this is VSS or ground. Okay, I'll call it as VSS only. This is your PMOS. So this is your, sorry, this is not PMOS. This is your CMOS inverter. CMOS inverter. Then what is layout? Whether this is layout? What I have written here, whether this is called as layout. This is called as diagram or it is called as schematic. What is the technical term what we use? Schematic. This is not a layout. Then what is layout then? So how this, if I draw the structure of this PMOS, right? What is the PMOS? This CMOS is formed. First we are going to form what? P substrate. Correct? First we are going to form what? P substrate. I think everyone has gone through your CMOS classes. First you have P substrate. In P substrate I cannot form what? PMOS. For that I'll put what? I'm going to put N well. So we are going to create what? N well. Inside N well we are going to form NMOS. NMOS source and NMOS what? Drain. This is NMOS source. This is NMOS drain. So similarly in P substrate I am going to form what? In P substrate I am going to form PMOS source and PMOS drain. Sorry, this is PMOS. So in this is N well. In N well we are going to form what? PMOS. In P substrate we are going to form NMOS. This is drain and source of your PMOS. This is source and drain of your what? NMOS. So now on top of this what you have? Silicon dioxide. Here you have silicon dioxide. Here you have what? Silicon dioxide. On top of this you have what? Polysilicon. Polysilicon is called as what? Gate. So this is your, this is the fabrication. This is polysilicon. Whether this is layout? But this is layout. No. So what you see from the top, if you write that, that is called as what? Layout. So how to draw the layout then? So this is your P substrate. Inside the P substrate, what you will form first? You will form this N well. So first to form this N well. So this purple color is nothing but your what? This is nothing but your N well. This pink color is nothing but your P substrate. Then after that you have what? I have to form source and drain. If I see from the top, I can see what? I can see source, drain and what? Gate. That's it, right? PMOS I can see source, drain and gate. NMOS I can see what? Source, drain and gate. So you draw that. So you have NMOS and center I have what? gate. So this is your source. Anything can be source. This is your source. This is what? Drain. What is this? Polysilicon. That is gate. Similarly, you can draw your PMOS. So in between I have to, this is my polysilicon. This is source. This is drain, and this is gate of my PMOS. What is this? This is PMOS. This is PMOS, and this is NMOS. So now, according to this connection, I have what? I should be also having VDD and VSS rails. This we call it as what? Rails. So I will be having this VDD and VSS also. This here I am having VDD. VDD is a metal layer. This is just a metal layer. This is VDD, and here I have what? VSS. So this is VDD. This is VSS. Just I have rails like this. Now this source of your PMOS. This source of your PMOS is connecting to what? VDD. So you make that connection. This source should connect to what? This is your VDD. Blue color is your VDD. So connect this source to what? VDD. This blue color is a metal layer. This metal layer is connecting to what? Is connecting to a diffusion. This pink color is what? P diffusion. This is P plus region. This is P plus region. So when I am connecting this metal to diffusion, I cannot connect directly. I should use what? I should use one contact cut. This is a contact cut. Metal and polysilicon directly cannot be connected. So I am using one contact cut here, black color. Similarly, this source of your NMOS is connecting to what? It's connecting to VSS. So make that connection. So source of NMOS is connecting to VSS. Then what is the left out thing connections? My gate and gate is what? Gate and gate is shorted. Gate of PMOS and gate of NMOS both are what? Shorted. So I can short through a metal layer, or I can extend this polysilicon only to connect them. Right? I can connect through this polysilicon only. Connect it and give a connection for a metal layer. Metal layer, I am making one connection here because, so this is our metal layer. This is for another cell to connect. The previous cell should make a connection to this cell, right? Output of previous cell is connecting to what? Input of this cell. So output of previous cell will connect to input of this cell through what? Metal layer. So for that reason, I am making the connection here. So this is a metal layer, but this polysilicon is a semiconductor. So I cannot connect directly. I should use what? I should use a contact cut here. This is a contact cut. And again, what is the last connection left out? Your drain of your PMOS and drain of your NMOS both are shorting. This connection is pending, that I'll connect it. Drain and drain, I'll short it. And that will connect here. So this is your V out. So this is called as what? Your layout. This is a layout of CMOS inverter. So I have drawn the layout of CMOS inverter, only CMOS inverter. But you should learn how to write the layout for AND gate. You should learn how to write the layout for OR gate. If you know, that is good. If you don't know, so we have basic courses also. This is an integrated course. You have advanced plus what? Basics. So in basics, we will cover digital, we'll cover Unix, we'll cover TCL, and we'll cover this CMOS. In CMOS, you have to understand what is PMOS, what is NMOS, what is the role of PMOS and NMOS, how they act as switch, right? Then you have to understand how this circuit works as CMOS inverter, how to write CMOS NAND gate, CMOS NOR gate, then fabrication steps. Then you have to learn about how to write the layout. So all these topics are covered in our CMOS basics courses. So this is called as layout. See, this is layout of only one cell. But what GDS consists of? GDS has, if you talk about GDS, GDS consists of what? The layout of, for example, this is your GDS, layout of all the cells. This layout of one cell, this layout of another cell, layout of another cell, layout of another cell. So output of this cell is connecting to what? Input of this cell. So output of this cell is connecting to input for this cell. So output of this cell is connecting to input of this cell. This cell output may connect to what? Input of this cell. So what are these boxes? All these are what? Layout of cells or layout of gates. NAND gate, NOR gate, XOR gate. So this is what that is what the GDS has. GDS has layout of what? Cells. So Foundry can understand only the layout. Foundry cannot understand any other thing. They can understand what? Only the layout. So now you understood that we are going to give the layout of cells to the Foundry, right? Foundry is a place where IC gets fabricated. So design is a place where we are engineers, we are working to design an IC. So we are going to create the layout of cells. Layout of cells means the cells are connected, and this layout we are going to, each thing is a layout like this. Okay. So this we are going to give to what? Foundry, and Foundry will fabricate IC for us. Then what is the role of physical design engineers here? So what physical design engineers will do? So to understand that, we should understand ASIC design flow. What is ASIC? Full form? So ASIC stands for what? Yes, application specific integrated circuit. So the ICs are fabricated or designed for specific application. The ICs are designed for specific application, that is called as what? ASIC design. So in this ASIC design flow, so first we start with specification. So then what is specification? What is present in specification? For example, any one company starts, they want to design an IC. So they will start with what? Specification. Then what is the content of specification? What they will do in the step, specification step? See, in specification step, they will collect what is the requirement for ICs. So what will be the requirement for ICs according to your knowledge? Right? When I talk about specification, what are the requirement for ICs? See, first thing is different functional blocks, right? This is my IC. What are the different functional blocks should be present in an IC? See, whether I want ALU, this ALU should be implemented with what architecture? Whether with RISC-core architecture or with ARM architecture, what type of architecture I have to use to build what? ALU. ALU is nothing but what? Processing unit, right? So what is that processor, or what is the ALU architecture I want? Okay, you implement, for example, mobile phone uses what? ARM processors, ARM architecture. Only processing unit is not sufficient. You want what? Memory, right? Memory is required. Memory control unit. Then you want Ethernet module. You want what? GPRS module. Apart from that, PCI controller module. PCI means peripheral controller interface. This is Ethernet module. This is GPS controller module. Then, if you have any memory compression techniques like JPEG, MPEG, all right. If you are going to implement that JPEG, MPEG, so those modules. So what are the different blocks, hardware requirements present in what? Hardware blocks required in an IC. First you are going to, so there is a clocking controller module, clock controller modules, or clock controller circuit. So what are the different blocks required in an IC? So first that we have to decide. So that is the first thing of, right, specification. So specification first is what is the requirement. So we are going to start with different functional blocks. Second thing is speed of IC, means what is the clock speed. So whether you think that entire IC will work with only one clock, no, need not, right? So I'll talk about EDA tools later, right? First we'll discuss about this part. So ALU or any processing unit, it may work with fast clock. Memory control unit may work with what? Less frequency clock. So this may work with one clock, that is clock 1. This may work with what? Different clock 2. So different units may work with what? Different clock frequency. So entire chip need not to be working with only one frequency, one clock. Different blocks can use what? Different clocks. So then my specification team should work with speed of IC or clocks. What are different clocks? Clock only is going to decide your speed of IC, right? If your IC is working with 1 gigahertz clock, then your IC is working very fast. If your IC is working with 500 megahertz clock, your IC is what? Half of the speed of the first IC, what I told. So your clock frequency is going to decide the speed of IC. So clocks for IC, what are different clocks? Next, battery. What is a, with what battery capacity your IC has to work? Battery capacity. See, battery capacity determines what is the voltage it can produce. If battery, your IC is taking more voltage, then what is the meaning? If your IC is taking, for example, your IC is working with 2.5 volts, then what is the meaning? It is going to have more power consumption. The IC which is working with 1.5 volts, which is going to have what? Less power consumption. So this is going to drain the battery very fast. This is going to drain the battery little bit slow. See, this IC will work slow, but it will take what? Less power consumption. If the voltage is less, it will power consumption is less, but it is little bit what? Slow. If IC is working very fast, it will take what? More voltage. If more voltage, it will take what? More power consumption. So here it is power consumption is very less. I can use what? Battery. I can use less capacity of battery. Here I should use what? More capacity of battery. So capacity of battery determines what voltage my IC works. So I can tell what is the voltage? Instead of battery capacity, I can tell voltage values. Voltage values used for IC. With what voltage my IC is working. Then estimated power consumption. So this IC should have this much power consumption, estimated power consumption. So these are different things which is decided in the specification stage. So specification, the fresher cannot involve in this, right? Because you cannot estimate all these things. Whether you can estimate, I tell that I want a chip for mobile phone. Whether you can estimate what is the functional blocks required. A fresher cannot. So very high experienced persons can estimate all these things through their experience, right? Past 10 projects I have worked, 11th project I can estimate what is if they come up with new IC. Okay, last IC i5 processor, this was the size, this many cores were there. i7 processor, okay, 3 functional blocks are added. Okay, this is the size of IC. So this much clocks I should use. This is the voltage value. This is the power consumption. So based on that, I can estimate what is the things. So highly experienced persons are involved in what stage? Specification stage. So they are also called as a chip architecture. Chip architecture team along with some business team are involved in this. So we engineers are not involved. So there is high level chip architecture team are involved. So after specification, what is the next step? What is the next step after specification? Yes, it is RTL design. So then what is RTL design? What we do in RTL design? We use Verilog or VHDL to describe the circuit, right? So you know what is Verilog or VHDL, right? So Verilog or VHDL are hardware description languages. So Verilog or VHDL we use to describe the circuit. So why this Verilog or VHDL? Why we are using this Verilog or VHDL to describe the circuit? For example, I am telling that ALU unit, right? Arithmetic logic unit. So why I should write the program in Verilog or VHDL? Why I cannot directly write the structure of that gate level structure? Yes, almost correct. See, any circuit or anything, it is very difficult to represent through its structure rather than we can describe through its behavior. See, everyone has written your truth table, correct? What is a truth table? Truth table is nothing but what behavior of the circuit, how the circuit is behaving. So if I tell write the truth table of mux, I will give you 2:1 mux, right? This is 2:1 mux or a D flip flop, right? So if I tell this mux, take this mux, which is having I naught, I1 and select line. Sorry, this output Y and I have select line yes. So if I tell what is a truth table, whether you can write yes or no. So if select line is 0, what is the output? I0. If select line is 1, what is the output? I1. This is a truth table. So if I tell implement this mux by using basic gates, how many can you do this? Write the internal structure of this mux by using AND gates or gate. So it is little bit difficult to think the internal structure, but it is very easy to draw what? Truth table. So truth table, whether I can convert into program, it is very easy, right? If s equals 0, what is y? Y has to take what? I naught. Else y has to take what? I1. Right? So this mux 2:1 mux, I can easily write the truth table. I can easily convert that into what? Program. So what is this? This is a behavior of the circuit, right? Behavior of the circuit, I can easily write what? I can easily write the program. But if I tell write the internal structure of this mux, how many can you write? To take an example of D flip flop, positive edge trigger D flip flop. So what are the inputs for D flip flop? D, Q, Q bar, and reset. You assume you have reset. So if I tell write the truth table of this, what is the truth table of this? If reset is 1, my Q will take what? My Q will become what? 0. If reset is 0, my Q is going to take what? D. Whatever is on D, that is passed to what? Q. But at what thing? At positive edge of clock. This is a behavior of what? This is a behavior of your D flip flop. So if you don't know what is behavior of D flip flop or mux, alright, you have to undergo your basic classes, digital classes. So this is asynchronous D flip flop. If reset is 1, my Q will become always what? 0. If reset is 0, whatever is present on D, that will be passed to what? Q. Means my Q is going to take what? D. Now, whether you can write the program for this VLSI program, that is very easy. I can write very easily. Like positive edge of clock, always. So there is a keyword in always at positive edge of clock. So I will start coding like this. If reset is equal to 1, if reset is equal to 1, what my Q will take? Q will take 0. Else Q is going to take what? D. That's it. This is a small program, small piece of program. So if I ask you to write internal structure of D flip flop, whether you'll write by using basic get, how many can you write in this classroom or in this meeting? How many can you write internal structure of D flip flop by using AND gate or gate? That was part of your syllabus, digital syllabus. Okay, others can write out of few. So that is why we will not go into, the designer will not directly go into what? Structure of the circuit. He will not directly enter into what? Structure of the circuit. He will write what? He will write he will describe the circuit in by using what? Verilog or VHDL. So using Verilog or VHDL, you can easily code the behavior of a circuit. So that is why we use what? Verilog or VHDL. So Verilog, by using Verilog or VHDL, behavior of circuit can be easily captured. We can easily capture the behavior of circuit by using Verilog or VHDL by using if statements. So Verilog supports what? If statement, case statements, if else statements. So by using this, you can easily capture the behavior of a circuit. So this is very small circuit. If you want to go for bigger circuit, how do you represent? I have written only small circuit. Bigger circuit, how do you, for example, you want to design an IC for ATM machine. How do you do that? So I have told you, design an IC for ATM machine. IC. How do you write the Verilog program for that ATM machine? D flip-flop truth table, you know. Mux truth table, you know. From that you can write what? Verilog program. So now I am telling ATM machine. I am using the word AC ATM machine because everyone know what is the role of ATM machine. Right? I am telling write the build an IC to implement what? ATM machine. Write the Verilog program. Then how do you write? How that the designers will write? So first implement using good. First implement use FSM model, finite state machines. FSM is also a behavior of a bigger system. How the bigger system behaves when we get the inputs, different inputs, how the bigger system is going to behave. That is captured in form of what? FSM. What is full form of FSM? Finite state machine. So if you have ATM machine, right? So it will be in the ideal state always. If your input is 0, right? It is always in what state? Ideal state. Input is 0 means you have not entered the card still. So your ATM machine always it will be in what state? Ideal state. If you insert the card, your sensor will read the card and one signal is generated. Means input signal is generated. Means input signal becomes 1. Then it will go to what state? It will go to next state called as pin entering state. So enter your pin. If your pin entered is wrong, then it will go back to what state? Ideal state. Means your pin entered is wrong. Means it is logic 0. If your pin entered is correct, then you'll go to which state? Next state. What is the next state? Enter the amount. This logic 1. Logic 1 means this pin entered is correct. Then you will go to next state. So enter amount. So whatever amount you enter, if it is valid, means you should be having that much balance. So I can enter 1 crore also, but I should be having 1 crore balance. Or I cannot enter 5043 rupees. So if that is also not valid. So I should put my amount only in multiples of hundreds or 500s. So if it is amount entered is valid, it will go to next state. If it is invalid, it will go back to what state? Ideal state. If it is valid, then it will go to amount dispatch state. See, my intention is not to discuss about the ATM machine role. If pin entered is wrong, it has to go back. It should wait for some time. My intention is not to do that. My intention is just to tell how the bigger machines are coded. Right? Simply assume that I have a ATM machine. If pin entered is wrong, directly go for what? Ideal state. Right? You assume that. So my next is amount dispatch state. If amount is dispatched, after it will go back to what? Ideal state. So now bigger machines I have converted into what? Different state. In this state, what it has to do? In ideal state, it has to do. It has to check whether card is entered or not. If card is entered, it has to output 0. If card is not entered, this state has to output what? Always logic 0. If logic 0 is outputted, it will be in the same state. If logic 1 is output of this state, it will go back to what? It will go to the next state. What is role of this state? the person will enter the pin. This says at this state has to verify this pin. If pin is correct, it will output what? 0. Sorry, if pin is wrong, it will output what? 0. If pin is correct, it will output what? 1. When this state is outputting 1, it will go back to which state? Enter amount state. So if amount entered, what this state should do? It should verify whether the amount entered is correct or not. So you have to write the program for that. How to verify the amount entered is correct or not. If amount entered is correct, you will go back to which state? You go back to next state. If it is wrong, you will go back to what? Ideal state. So now your role is to write the Verilog program for each state. Write the Verilog program for each state. What is the role? What each state is doing. So now bigger design, you convert it into what? Different states. Now write the Verilog program of this state. Write the Verilog program for this state. Write the Verilog program for this state. What it is doing. Write the Verilog program for what? This state. What it has to do. So this is how you are going to convert the bigger design into what? In the form of what? Behavior. This is a behavior of your ATM machine, right? So behavior of complex design is called as what? FSM, finite state machine. First you will convert to finite state machine, then you will write what? You are going to write the RTL code. So none of the front end engineers will not write the code for ATM machine. They will write for I2C protocol. They will write the protocol for SPI protocol. They will write the for PCI protocol, peripheral control interface. So I have taken the example for ATM machine because you don't know what is PCI interface. To explain PCI interface, it will take 3 months. So I cannot explain that now. So just I have taken this example. So bigger designs, first they'll write the states, and now they will start coding the behavior of what? Behavior of each state. So that is how the RTL programs work. So RTL programs uses VHDL or Verilog to capture what? To capture the behavior of circuit. So describing the circuit behavior is easy. Directly going into what? Its internal structure. I cannot directly code what is the internal structure of a circuit. I cannot directly code what is the internal structure of my ATM machine. Right? So first I will describe this ATM machine in form of behavior by using what? Verilog or VHDL. Then what is the next step? Now your design is in what form now? Yes, it is in RTL form, or I can tell it is in what form? Behavioral form. It is in the behavioral form. It's not even in the circuit form, correct? This is not the circuit. This Verilog code is not a circuit of any. It is just a behavior of what? Mux. This Verilog code is just a behavior of what? D-fifth law. Now your design is in the behavioral form. It's not in the circuit form. Whether this behavioral form I can give to Foundry. Foundry accepts what? Only layout of cells. I cannot give to Foundry. Right? What is the next step? What is the next step? Functional verification, or is also called as design verification. This is one of the interesting course. Functional verification or design verification. This is also one of a separate course. Each step is a separate course. RTL design is a separate course. Functional verification is a separate course. All this entire thing one engineer will not do. Chip architecture team is what? It's not separate course. You cannot learn through course. This can be learned only through experience. You can go to this position only through experience. But RTL designer is separate course. You can become RTL designer, but what you have to learn? You have to learn your Verilog, VHDL, and system Verilog. How to use system Verilog. So next is what? Functional verification or design verification. What we do in this stage. I have written the program. For example, you assume that I have written the program, RTL program for what? Mux. I want to verify this program is working like Mux or not. What I should do? This is the Verilog program for Mux. This I have to verify whether it is working like mux or not. What I should do? Apply different inputs like yes, I naught, I1. Apply this different inputs and verify what is the output. Right? My S is 0, I naught is 0, I1 is 0. What will be the output? As select line is 0, my output Y is going to take what? I naught. What is the value of I naught? 0. So in this case, Y should take what? 0. So my S is 0, I naught is 0, I1 is 1. So when select line is 0, my output should take what? I naught, which is already what? 0. Now 1, 1, 1. My I1, my select line is 1. My Y will take what? I1. What is the value of I1? 1. So this 1 is the output. So applied, this is called as test case. Applying this one combination of input is called as what? Test case. This one test case. What is this? Second test case. What is this? Third test case. So apply this different test cases to your Verilog program and verify what is the output. That is called as what? That is what you do in what? Functional verification. So functional verification is nothing but I can tell verifying functionality of design. So where is design now? Design is in what form? Design is in VRL form, means in the Verilog form or VHDL form. So verifying functionality of design by applying test cases. Apply different test cases. So I can easily apply test cases for my mux. So how many combinations I'll get? I have 3 inputs. How many combinations I'll get? 0, 0, 0, 0, 0, 1, 1, 0, 0, 1, 0, 1. Totally how many combinations I'll get? How many combinations of input? So I'll get 2 power 3 combinations. Including the 0, 0, 0, it will be what? 2 power 3. But you take my ALU. ALU is having, for example, 128 bit input. Then how many combinations? 2 power 128. I cannot apply all this 2 power 128 and I cannot verify this ALU program. I cannot do that. Then I have to decide which combination I have to use so that I can verify this circuit efficiently. So that is the main role of what? That is the main role of your functional verification engineer. So this test cases what you apply, I cannot apply whatever I like. If I apply like that, what happens? The combination of test cases starts increasing. Apply the test cases carefully so that I can verify this circuit efficiently. So what type of test cases I have to apply? So that is told by your UVM. How to apply the test cases for bigger designs. So what is UVM? Stands for Universal Verification Methodology. So UVM tells a step-by-step process of verifying the bigger designs or complex designs. If you have very big design, how to verify that? What type of test cases you have to apply? That is called as UVM. So along with UVM, you should also learn system Verilog. Verilog, system Verilog, and UVM. If you learn all the 3, then you can become what? Functional verification or design verification engineer. System Verilog is also Verilog, but what is the difference between Verilog and system Verilog? Yes, system Verilog is combination of Verilog and your C++. Both combined together is formed as what? OOPS means object oriented programming. It is a main main construct in your C++. C++ and Verilog combined together formed as what? System Verilog. That is very helpful to verify the bigger designs. Smaller designs is very easy. apply different test cases and verify. But to verify bigger designs, I have to learn all these things. UVM tells how to apply test cases for bigger designs. What is the thing you have to look out? What type of test cases you have to select? All right, that is what UVM tells. System Verilog means it is programming, or I can tell it is a language used to do design verification. It is a combination of Verilog and C++. Both together is called as what? System Verilog. So after verifying your design is in what form? VRL form. Means it is in the Verilog form, not even in the gate form. This design I cannot give to what? I cannot give to a foundry. Then what we do is, then we go to the step called as synthesis. What is synthesis here? Yes, correct. You have, you have design in the behavioral form. Means we have described the circuit through its behavior, how it's behaving. Converting this behavioral form design to the gate level form is called as what? Synthesis. So synthesis is nothing but converting your RTL design, converting RTL design to gate level design. And who is going to tell what gates I should use for converting? I am converting RTL to what? Gate level. RTL is there, convert to gate level. Then what gates I have to use? Whether you can use AND gate, whether you can use OR gate, whether you can use full adder, whether you can use half adder. Who is going to tell that what gate I should use? So the same synthesis you have also done during your FPGA design. So your RTL is converted into gate level design. What is a gate level design? Gate level design means a connection of your AND gate and is connecting to what? OR gate, like this. This is called as what? Gate level design. So who is going to tell what gates I have to use for conversion? Converting, we are not going to do it. Tool is going to do it. Which tool? EDA tool. EDA tool is going to do that. Now, how the tool gets? What gates I have to use? How the tool knows that? Yes, we have to give that. So for that reason, we should discuss what are the inputs for synthesis. So one of the input is your what? One of the input is your RTL program. That only we have to convert, right? Your RTL program. RTL is in the form of what? .v means Verilog. One of the input is your RTL. Second input is your library or liberty files. It's also called as liberty file. That is the extension is .lib. .lib means after the file name you will be having extension called as what? .libs. So .lib is a file which contains information of standard cells. It has information of standard cells. So that is present in the liberty file. So during synthesis we have to give this liberty file. So what is the standard cells meaning? Standard cells. What is meaning of standard cells? Your NAND gate, NOR gate, OR gate, AND gate, XOR gate, inverter, buffer, D flip flop, mux, full adder, half adder. So all these gates are called as what? A few gates, basic gates which is required. right? All these gates are called as what? Standard cells. So these standard cells information is present in what? Liberty file. So what information we have? What type of information? I've told information of this gate. What information? What is the area of this gates? Area means layout area. So for NAND gate, I will be having the layout, right? This is a layout of what? NAND gate. So what is a, if I multiply width by height, I'll get what? Area. So what is the area of the gates? So I'll be having area, functionality. Functionality means what is NAND gate will do? What is the functionality of NAND gate? For example, input is A. It will do what? A and B, the whole bar. Correct? That is the functionality of what? NAND gate. So that is called as functionality. So functionality equation, what it will do? So delay of the gate. Delay of all the gates. How much delay each gate is going to take? Delay of the gates. After applying the input, after what time you will get the output? I apply input here 0. I am getting the output after 2 nanoseconds. Then what is my gate delay? How much it is? 2 nanoseconds. So delay of the gate. Then how much power each gate is going to consume? Power consumption. So I am telling in the outer layer. So when you go to advanced PD, you will open these files and you will see what is present in it. Each and every line you will understand what is present in this file, how this delay is encoded, how the power information is present in this, how the functionality is defined, how the area is defined for each cell. For each cell, you have what? Area, functionality, delay, and power consumption information in what file? Liberty file. My tool will pick these cells from the Liberty file and it will convert RTL to what? Gate level design. I am not going to do that. Our designer is not going to do that. Tool will do that. Then what is the role of designer here? So because of that only, right? Many companies are easily outsourcing their project. Intel, Qualcomm, AMD, or Nvidia, these companies, they will not hire the employees, all the employees. They'll only hire only few employees who are ready to set the project. So all those projects are outsourced to service-based companies. So these are product-based companies. They are going to fabricate the chip. All these projects are easily outsourced to what? Service-based companies. Service-based companies are like few companies you have Mirfra, Chip on Time, Altran, Sientra, Capgemini, Tech Mahindra, Marvin Semiconductors. So there are few service-based companies like this. So service-based company engineers work for projects of what? Product-based companies. So product-based companies like Intel, Qualcomm, AMD, Nvidia, all those companies will easily outsource their project to what? Service-based companies, because most of the works is done by what? Tool itself. Tool only will do most of the work. You have to just find out, is there any error? If there is any error, you have to identify what is that error. A 10th standard student cannot identify that, right? Or a PUC student cannot identify that. The student who is having the knowledge of the tool and knowledge of the VLSI can identify that what is the error. See, when you get any error or your bike is having some problem, if you start repairing this bike, you will take 2.5 days to repair that bike. You take that to garage, he will do it in 5 minutes. Means what the person will do in garage, he will identify what is the problem, exact problem. Through his experience, he will identify what is the solution for that, what I should do. So he will solve the problem in 5 minutes. So that is what the role of engineers nowadays. Identify the problem and come up with what appropriate solution. That if you are capable of doing that in 5 minutes, your problem is solved in 5 minutes itself. But if you are not able to identify what is the problem, your problem will go for even 10 days. A smart worker will identify the problem even in 5 minutes. That's it. Fix the problem, gone. Your tool will take over. That's it. Our projects are running for 2 to 3 days. If I start one command, it will automatically run for 2 days. I don't have any work for 2 days because everything is automated. Every domain is automated. But the real intervention of me is required when my program stops in between. It will throw some error. Now, what is the error? I have to read. And what action I should take for this error. So I can understand what is the error and I can decide what action I should take. If I take appropriate action, my problem will be solved in 5 minutes and again my program starts running. If you doesn't understand what is the problem, you will waste your entire day or 2 to 3 days in solving the problem. So you will start your design after 3 days. Again, start running after 3 days. So the main role of engineers nowadays is just to identify what is the problem and come up with appropriate solutions. That is what the role of engineer. So synthesis is done by the tool. You are not going to do it. So your synthesis tool will convert RTL to what? Gate level design by picking the cells present in what? Liberty file. You have to give this as an input. So there is one more input for this. What is that? Yeah, one more input for this. SDC file. Synopsis design constraint file. So what this file consists of? This file consists of mainly the timing constraints for my design. See, what do you mean by constraint? See, my program is converting from RTL to gate level gate level design. It is very easy. Conversion is very easy. But if I tell some constraints meet this requirement, while converting meet the requirement, then it is very difficult to do that. See, if your parents tell in the morning, go to VLSI Guru and come back, use whatever mode you want. What you will do? Easily book a cab, sit in a cab, watch some reels, and come back to VLSI Guru. Again, go back to your home. It is very easy. But your father and mother imposes a rule like go back to VLSI Guru and come back within 20 rupees. In for ladies, it is free. Right? Nowadays, buses are free. And for gents, it is very difficult. 20 rupees means what you have to do? Wake up in the morning, walk half a kilometer to bus stand, catch a bus, and come back to VLSI Guru and walk here for 2 minutes. Again, wait for bus. And it is very difficult. So that 20 rupees is called as what? Constraint. So I have to put the constraint to my design. You don't convert your RTL however you want. While converting, you meet this constraints. Then what will be the constraint here? What type of constraint you can put on the design? So you will tell that my design has to work with this much amount of clock period, right? This is a clock frequency. The design should work with this clock frequency. So clock frequency, mainly clock period is mentioned here. Clock period. You can also put some area constraints. The design should have maximum this much area. Sum of all the cells area should not exceed this much area. So in the such a way you convert RTL to what? Gate level. So see, apart from that, you have different things like set input delay, set output delay, set driving cell. So all those things is included in SDC file, but I cannot explain all those things now because that is part of STA, static timing analysis. So when we do STA, you will understand all those things. Why we use set input delay, set output delay, set driving cell, set load. So all these things are part of what? SDC. For time being, you understand that you have what? Clock period. So your design should convert your RTL to what? Gate level design. While in the conversion, it has to meet what? It has to convert to work with this clock frequency. Clock period means it's inversion of what? Inversion of clock frequency. Inversion of clock frequency is called as what? Clock period. So your design we should work with this clock frequency. That is what the constraints you are putting here. So your design will convert your RTL to gate level design. Then what is the output? What is the output of this? What is output of synthesis? See, you are getting gate level design. So that gate level design only is the output, right? So that is called as gate level netlist. Gate level netlist. It is also a Verilog program. So my input is also Verilog program. Output is also Verilog program. Then what's the difference between both? What's the difference between RTL and gate level netlist? Yes, RTL is in what form? BRL form, but gate level netlist has only gate and its connections. It will be having only gate and its net connections. What is present in gate level netlist? You take this example. So now this is your design. You assume this is your design. So this design has first one AND gate. A, B, Y. This I'll call it as input M, N. Mn is a port of my design, input ports. This will be connected to one OR gate. So I have A, B, and Y, and this is converted to one inverter. It is going to the output. Output I'll call it as S. This is A and Y. This is your, for example, you assume that MNO. This is your gate level diagram. What you got after converting your RTL to gate level structure. This is your gate level diagram. What you got. I have only 3 gates for simplicity. Then what is a netlist here? How to write a netlist? See this intermediate signals. This intermediate signal is not connecting even to inputs or output. These are called as nets. This I will call it as N1. This intermediate net I will call it as what? N2. Then how to write the Verilog program? So Verilog program starts with what? Module, temp. What are the inputs for this? M, N, O. What is the output? Yes. What are the inputs here? First I have to declare the inputs. What are the inputs? M and N and O. What is the output? Yes. Next I have to declare my intermediate signals. Intermediate signals are declared with the keyword called as what? Wire. 2 intermediate signals are there. What is that? N1 and N2. This is same. RTL is also having same thing and your netlist is also having same thing. But in the RTL you will be having what here? Behavioral description by using if statement or Boolean equations. But in the gate level netlist, now I am writing gate level netlist. So gate level netlist should have only gate and its connections. It should be having only gate and its connections. So this is AND gate. This is OR gate. This is inverter. So now first I'll describe this AND gate. So this AND gate name is AND2 in my library file. This name is present in which file? This library file. So what is the name of the gate? AND2. Why this 2? 2 indicate it is what? It is a 2 input AND gate. So my synthesis tool will give one instance name. This U1 is called as what? Instance name. Why this name is given? Because in design I can have n number of AND gates. So I should be having difference between one AND gate to another AND gate. So my synthesis tool itself will give U1 for this AND gate. If I have one more AND gate, my synthesis tool will give as what? U2. If I have one more AND gate, it will give it as what? U3. Like that. So my synthesis tool will give this instance name. Next, I have port mapping. This is called as port mapping. This is the name present in my which file? Library file for AND gate. This is an instance name given by synthesis tool. Next, I have port mapping. Port mapping means dot A. Dot A. This A pin is connecting to which port? M port. So dot A is connecting to M port, comma. Dot B means B. This B is connecting to which port? N. So I should write N, comma. This Y. Y. See, input and output of your cell is called as pin. Input and output of your block. This is called as your block. It's called as what? Port. This is called as port. And this is called as what? Pins. Input and output of cell is called as what? Pins. But for complete design is called as what? Port. So here M, N, O and S is called as ports. But is A, B, Y is called as what? Pins. So your Y pin where it is connecting? So next I have dot Y. This AND gate Y pin where it is connecting? It's connecting to which net? N1 net. Next, what is the next gate you have? OR gate. Instance name is U2. Next, A. A pin of your OR gate where it's connecting? It's connecting to N1 net. B pin where it's connecting? It's connecting to O. Y pin where it's connecting? This Y pin. It's connecting to what? N2. This inverter. U3 instance. A pin where it is connecting? A pin of inverter where it is connecting? N2 net. Y pin where it's connecting? Yes. Then end module. So this is your gate level netlist. It has only gate information, correct? Apart from gate information, you should not be having any other commands like assign command, if statement, case statement. Something should be present. In the in the gate level netlist, you should be having only what? Gates and its connections. So whether connection is present in this Verilog program or not. Here connection is present or not? Connection is present, right? Because this N1 is connecting to what? Output pin of your AND gate, and the same N1 net is connecting to what? It's connecting to A pin of your OR gate. Means input pin of OR gate. Then the meaning is what? Output is connecting to what? Input. Here also you can see here. This Y is the output pin of your OR gate is connecting to N2 net, and that same N2 net is also connecting to what? A pin of your inverter. So then there is a connection. Connection is maintained here. It's clearly understood that this output pin is connecting to this input pin. This output pin is connecting to what? This input pin. So we are not going to forward this diagram to the PD team. We will forward this netlist to the PD team. My tool can understand there is a connection. This is called as what? Gate level netlist. So gate level netlist should have only gate and its connections. No other statements. Assign statement should not be present. Assign statement means what? Assign y is equal to a and b. This is called as what? Assign statement or if statement or case statement. Something should be present. Only should be having gate and its connections like this. That should be present in your gate level netlist. So this is the output of synthesis team. Now we have come one step down from the behavioral form. We have jumped to what now? Gate level. Now my design in the gate level. but it is not present in what? Layout level. It is present in what level? Gate level. Whether this gate level my foundry can understand. Whether my foundry can understand this gate level, my foundry requires what? So that is the role of physical design engineers. Convert this gate level information to what? Layout level. So we are the last step before sending the design to what? Foundry. Generate the layout and send the layout to the foundry. They will fabricate IC for us. Right? So next is, see, before physical design, one team comes into picture that is called as a DFT team. Design for testability. Whatever steps I am writing here, right? This is one of the course. This is one of the course. Synthesis is one of the course, but we will cover in part of what? PD only. So DFT is separate course again. Design for testability again, it is what? Separate course. So what is the role of DFT engineers then? See, when my chip gets fabricated, when my chip is fabricated, this is a chip. So this is a metal layer inside a chip. Two metal layers. Actually, two metal layers should be like this. But we are fabricating in nanoscale. Nanoscale means even we cannot see through our eyes. Smallest unit in your scale is milli. See, if you want to talk, you can go outside and talk. Right? Talking slowly is okay, but it should not disturb our class. So this is the metal layer which has to be fabricated according to our requirement, but foundry cannot fabricate like this because foundry cannot fabricate the metal. See how to form this metal layer. My foundry cannot form the metal layer only in this region. My foundry will fabricate metal layer from here to here. Remaining regions it will remove through what? Acid. This region they will cover through mask. Here they will cover through what? This region they will cover through mask. This they will cover through what? Mask. Entire region they will treat with acid. But this region is not treated with acid because it is covered through what? Mask. We already covered it. But remaining regions we treat with acid, remaining regions are removed out. Then I will get metal layer only at this region. Do you think that when I treat this entire region with acid, I can get this planar structure? No, I will not get planar structure. I will get the structure like this. So here, without our notice, both the metals are what? Shorted. And this IC cannot work. Even foundry cannot identify this. Both are shorted. Because you will be having lakhs of metals like this inside. My foundry cannot identify this metal is shorted like this. Then who is going? And this chip, if we use in mobile phone is corrupted and the mobile phone manufacturer will lose the market. Once the IC loses the market, right? If IC is failed, it's okay, but IC should not lose the market. See, one IC to fabricate one new IC, they will invest more than 500 crores to pay the engineers, to pay to the design team, to pay to the foundry. So overall investment will be more than 500 crores. One IC which is coming to market, right? Its cost will be not more than 2000. It will be less than 2000. Our mobile phone only is 10,000, including all battery, package, everything. It is 10,000. So one IC is not more than what? 2000. So imagine if they want to cover this 500 crores of investment, how much IC they have to sell? If they want to sell this much IC, if one IC goes into the phone and that phone is not working, in social media in 2 days it will spread. This phone is not good. Then they lose a market and they will suffer huge loss. So one corrupted IC should not come into the market, not even single IC. Then how to test that whether this IC is working properly or not? So testing an IC after fabrication is called as a post silicon validation. Silicon validation. So what they will do is they will apply some test cases inside an IC and they will verify some output test cases. Whether this test case is matching with this previous simulated test cases. Here we have test cases, right, in our functional verification. During functional verification, I have the test cases. During my functional verification, I have applied the input. I have got what is the output. The same test cases I will give to what this post silicon validation team. They'll apply different inputs. I am not applying input to the software. I am applying input to what real IC. If my IC is fabricated for phone, I cannot connect antennas and I cannot check it whether it's working properly or not. So what we do is we apply some test cases and we verify that output here. To facilitate this testing, my DFT team will add some additional logic inside my IC. Additional logic means they will add some additional gates inside my IC. For what purpose? So that this testing can easily happen. So if they apply inputs, they should be knowing where these inputs are going, right? If they want to know where these inputs are going, through what logic they are going inside. Inside an IC, there will be more than 50 to 70 lakh cells. 50 to 70 lakh standard cells. So when I apply any test cases, I should be knowing where it is going, where the test case I have applied logic 0, through what gates it is going. I should be knowing, and it is coming output of this. So I should be knowing what are the gates present inside. I should be having that control. To make this control possible, what my DFT team will do, they will add some additional logic inside this. Additional logic means additional cells they will add. They will not add after fabrication. After fabrication, we cannot add it. They will add at what stage? They will add in the netlist. They will add in the netlist. Netlist, they are going to add some additional cells so that IC can be easily tested after fabrication. Testing doesn't happen now. Testing happens after the fabrication. But to facilitate that testing, they'll add some additional cells in the design without affecting the functionality. Functionality should not be affected. So that is a role of DFT engineers. So DFT engineers, they'll add some additional logic so that IC is easily testable after fabrication. Yes, if we are adding in the netlist, right? Netlist only we are going to convert to the layout level or GDS level. So that GDS only we are giving to Foundry. So Foundry is going to fabricate these cells also, right? Which is added by DFT team. These cells will be present in an IC. So where we'll add these cells? We'll add the cells in what? Netlist. DFT team is going to work in the software itself. They are not going to work in the hardware. So they will add the cells in gate level netlist itself without affecting the functionality. See, you don't ask me how they will add the cells. That is separate. I told you that is separate course. Scan chain they are going to insert. That some part of that you will learn even in PD because PD engineers also need this one. What is scan chain insertion? How the scan chain is working. So even we will discuss even in your advanced physical design some part of DFT. Not complete part. I cannot discuss what is automatic test pattern generation ATPG because that will take again 1.5 months to discuss. So I cannot discuss. But what is scan chain, how the scan chain are inserted, that we'll discuss even in advanced part. So they will do some logic like I'll mention what they will do. They will do scan chain insertion. Next it is boundary scan. Yes, yes, yes. Area will increase obviously because some cells are added, right? Additional cells are added. So in the netlist area gets increased. See, but we are not at the physical level still. We are just at the logic level. So this is required, because if this is not added, we cannot test the chip. If this chip is not tested, see, in generally what happens is, out of 100 chips, minimum 40 chips are thrown away. Only 60 chips are functioning properly. 40 chips are obviously thrown away. So obviously yield of any design will be 60 to 70%. Means yield means out of 100 ICs, how many ICs are working properly. So minimum they will throw 30 chips. Only 60 chips will work properly. So who is going to test that? That is tested in the phase called as what? Post silicon validation. To facilitate this process, our DFT team will add this scan chain in the design. They'll add boundary scan. So they will do automatic test pattern generation. ATPG. BIST, right? Built-in self-test. For memories, they have BIST, built-in self-test, or MBIST, memory BIST. BIST stands for built-in self-test. So all this process, all these things you have to learn when you are part of what? DFT engineer. See, DFT engineer is different and physical design engineers are different. Both cannot work, one person cannot work parallelly. So DFT engineer will be adding scan chain, you will be doing physical design. So industry works in phase, so that all these things will understand how DFT engineer and physical design will engineer both will work at a time. After DFT engineer only physical design has to work, but industry both will work at a time. Because see, we work in, see what happens is physical design engineer will not do physical design only at once. They will do 4 times for only same project. Because they will do first a trial design. Next they will do a little bit proper design. Next they will do a little bit proper design. At last they will do what? Final design. Because when they are doing trial design, your netlist is not completely freezed. Means netlist may be changing, because RTL team still they will change some logic. Right? RTL team is still changing some logic, but what you can do is you can estimate how can be your result during physical design. For example, first netlist I generated, it is having, you assume that I have 5 lakh cells, but still my netlist provider tells, or my RTL team tells, this netlist is not completely freezed or not completely ready. Still there is a modification happening. So next time modification happens, how much cells do you think it will change? Hardly 500 cells. So next time it will be like 5 lakhs, 500 cells. So from the first release of RTL to second release, they will take 1.5 months. Whether in this 1.5 month physical design team will sit ideally? No. Whatever the first release you have, take this first release and start doing your physical design. That may not be a proper design because the netlist is not completely ready. But still you can get an idea how will be your floor plan. What is the results you are getting from that? You can get an idea. It's like a practice match before the actual match. So like that, this type of things happens 4 times. First phase, second phase, third phase, phase 4. 4 phases will be there. So first 2 phases are just a trial run. Third phase, or some industry will freeze at third phase. Some industry will go for fourth phase also. It depends upon RTL. If RTL changes even in the previous day, tomorrow is the last day for tape out. If RTL changes in the previous day, then again physical design engineer has to work from the beginning. If RTL changes, we have to work. We don't have any other option. If RTL changes is leading to only changes in 10 cells, it's not going to. Earlier cell count was 5 lakhs. Now at the last day, before the last day of tape out, RTL is changed. Now I have only 10 cells changed from previous net list to this net list. Only how many cells have changed? 10 cells have changed. Now whether you will go for fresh design again? No. You can incorporate this change in physical design directly. That is called as functional ECU. 10 cells change or 20 cells change, you can incorporate in the last stage itself. But if the cell changes happens more than 50, you should do the design again from the beginning. Physical design should be done again from the beginning. So like that. So when we are doing the any 5 lakh cells, we got gate level netlist. My DFT team has not added any logic. They are adding the logic. You can parallelly do the physical design. You can just get the results how it is. After DFT team adding the logic, then only we should do physical design. That is actually a right thing. But even without adding this scan chain, I can do physical design for these cells, whatever netlist I got. I can be doing because just I will get what is the how many violations I have, whether that area is floor plan area sufficient or not. So whether how many shots I will see. So all those things I can check. So next comes the role of what? Physical design engineers. And what is the role of physical design engineer? Now design is in what form? Gate level netlist, this DFT team will add some few cells, additional cells, or they'll modify the existing flip-flops. Normal flip-flop they will modify to scan chain flip-flops. That they will do it. That is scan chain flip-flops also present in Liberty file. They'll just change normal flip-flop change to scan chain flip. That you will learn later. What is the role of what is scan chain flip-flops? So now my design, it is in what form? It is in gate level form. Whatever you are seeing here is just a symbol. It's not a layout. This my foundry cannot understand. So I have to convert this gate level design. Role of physical design engineer is converting gate level design to what I have to convert? Layout form. So generally we not call it as a layout form. We call it as what? Physical form. Is role of physical design engineer. So physical design engineer has some goals also. Converting is easy, but converting I have some goals also. Goal, see, writing exam and passing is very easy, but what is your goal? You have to secure 98%. That is difficult. So similarly, converting gate level engineer, gate level design to physical layout is easy, but I have some goals. One is area. I have to do physical design in allocated area. My vendor tells that your chip size is 400 millimeter square. I have to complete my design only in 400 millimeter square. So next thing, what? Timing. Timing is very important. Timing here is like your STA, static timing analysis you will do. So you have to learn about static timing analysis. These are the goals. You have to meet the timing. Next, what you have to do? Next, you have to do the design so that it can be fabricated easily. Because you are the last person who are going to generate what? Layout. See, you are going to generate the layout where two metal layers are crossing each other. Then here is there is a short, right? You cannot give this layout to what? Foundry. So you should follow the rules given for follow rules for fabrication. So we have to follow the rules for fabrication. What are the rules? then only my foundry, because foundry is having machineries. What are the rules imposed by foundry? We have to follow that. My foundry tells that from one metal layer to another metal layer, minimum you have to leave 0.5 micrometer spacing. If you tell that I am not going to leave 0.5 micrometer from one metal layer to another metal layer, my spacing is 0.25. Then my foundry will tell that I'm not going to fabricate. Go. That's it. So we have to follow what is the rules for fabrication given from foundry. So we should follow all the rules. That is called as design rules. DRCs. And implement design for manufacturability. I am following the rules found implemented by foundry. My foundry also tells that follow few procedures so that I can do the manufacturing easily, so that your design is manufacture ready. It is ready for fabrication. Follow some rules like add tap cells, add end cap cells. End cap cells and tap cells are not the standard cells. These are the cells added to my design so that my design is easy for fabrication. During fabrication, no harm is going to happen for standard cells. Right? When the PM is coming along with that, even our military force will also come. Why? So no force, no harm should happen for our VIPs or chief guest. Similarly, who are the chief guest here? Our chief guest are our this cells present in what? Gate level net list. So during fabrication, they should not harmed. They should be fabricated properly. If they have to be fabricated properly, side beside them, I should use few cells that is called as end cap cells, so that they are not affected. So that is called as implement design for manufacturability. So there are few things which we have to follow. This is called as BFM. Follow those rules. So these are the goals of physical design engineer. But what we have to discuss is steps in physical design. The steps in physical design. So what are the steps in physical design? I am not going to in depth of steps that in depth you are going to learn in your advanced part. Just I am going to, because we have shortage of time, right? Till I have many things to discuss. Just I'll discuss in brief. Right. First step is what? Floor plan. Next step is placement. Third step is CTS. Fourth step is routing. Next step is sign off checks. These are different steps in physical design. First step is what? Floor plan. So in this floor plan, again, there are few steps. One is create core area and die area. So what is create core area and die area means? We have to create our chip structure. So I have to create this core area. I have to create this die area. So this inside thing is called as what? Core area. Outside thing is die area. So I cannot create this core area very small, or I cannot create very big. My core area should be sufficient to occupy all the standard cells. It should occupy all the standard cells. So inside this core area, we are going to place the cells. These are standard cells. These are the layout of standard cells. We are not going to draw the layout. Physical design engineers are not going to draw the layout of standard cells. that is drawn by a team called as layout team. That is a separate team again. So we will get this layout of cells in a file called as left file. What is the file name called as? Left layout exchange format. So in this file, I have whatever the cells present in .lib, whatever cells present in .lib, for all these cells, I have the layouts present in which file? Left file. Who is going to draw the layout? For NAND gate, who is going to draw the layout? NOR gate, we are not going to draw the layout. Physical design engineers will not draw the layout. But you should be having the knowledge of layout. Because at the last, if you get any errors, you should be in a position of understanding that. So you should be knowing what is content present in layout, but we are not going to draw the layout. So inside this core area, we are going to place what? Standard cell layout. That is done in the placement step, not now. So this core area should be in a position to occupy all the cells, all these standard cells present in the netlist. These standard cells. So here I have written how many cells? In reality, how many cells you will be seeing? 10 lakh to 15 lakh cells. We will be having 10 to 15 lakhs. So we generally not call in lakhs, we call in millions. What is 1 million? 10 lakhs. So generally you will be having 2 or 2.5 million. 2.5 means 25 lakhs. So you will be doing physical design for 25 lakh cells at a time. One command if I run in physical design, that will take 2 days to run. In a tool, if I type one command like placeout, that will take 2 days to run. 2 days I don't have any work. That command is running. Right? That much complexity the design will be. Here we cannot use that much complex design because during the course I am telling only one command. Like that I have plenty of commands to run. If I ask you to run like this one command, right, it will take years together to complete the syllabus here. So we will do the design with a cell count of 50 to 60,000. Why we are doing with less cell count? Why with now with high cell count? I told you, right? One command will take 2 days. See, my recent run was 11 hours for first command, first step. So I have like that 15 steps to be done. So one command is taking 11 hours means you imagine. So for that reason, we work with lesser cell count. Means the runtime is less. See, if we execute that command, you need not to do anything. I cannot give holiday for 2 days holidays for the courses. You complete after this command is completing. I cannot tell like that. And if there is any error, we have to debug the errors for every student, every 70 student. For that reason, we work with little bit lesser cell count, like 50 or 60,000 cell count. But industry works with what? You will be having 25 lakhs cell count. So in this core area, we are going to place 25 lakh cells layouts. So here we are going to place the layout. I am not going to place, my tool is going to place. This is done only in the placement stage. But what is the first step? Create this core area and die area. So you have to create this core area such a way that it is going to occupy all the cells present in the netlist. So you have to plan that. So that is a plus all these cells. Here I have 3 cells. You imagine you are having 25 lakhs cells. So what is the next step after port placement? Next step is port placement. Port placement means place the input and output of your design, right? In between this core area and die area, place your input and output of your design. These are a piece of metal layers. This is input and what is this? These are output. Through inputs, the signal will come inside. Through output, the signal will go outside. So place this. These are ports. Place these ports. So you will be having 500 to 600 ports. Whether each port you will be placing manually? No. You have commands to work on that. For that reason, to work on these commands, you should be knowing TCL, tool command language. Your tool can understand only TCL. So physical design engineer should be knowing what? TCL. So after port placement, you have macro placement. So macros, what are macros? See, macros are the previous layouts. Macros are not small designs, it is a bigger designs which can be reused. Previous designs can be reused. For example, I have previous IC where few blocks are same. That layout I will reuse. This is bigger design will be having some standard cells inside. For this, I will not write the RTL. I will not do synthesis. Directly, I will use the layout of what? Bigger designs. Like your sambar powder, right? Your mother is not preparing the sambar powder from the scratch because it's readily available in the market. Directly purchase from market and directly use it in the dish what they are preparing or your puliyogre powder because it's already available in the market. Similarly, few designs which are already available, why you will write RTL for that? Why you will do synthesis? So directly the layouts you can use it. Layout you can directly reuse it. So those are called as macros. If you have any macros in the design, you use it. So these blocks which is already used in the previous project, I am reusing it. I am already having layout for this. I am directly reusing it. So place this macros first. This is a macro. So after macro placement, what is the next step? You have power planning. So what are macros? Macros are complex cells. They are not standard cells. So why we do macro placement first? Macros are complex cells. So where the design is already available for us, layout is already available for us. So if the layout is already available, the polygram mix is already available. I need not to prepare from the beginning, right? Similarly, I need not to write for this block. Layout is already available. Don't write the RTL code. Don't do synthesis. Directly use the layout for that. Directly use as part of your design. So generally we do macro placement first because macro count will be less in number. Macro count is less in number. Generally you will be having 10 to 300. The count will vary from 10 to 300. It depends on design. Some designs generally you will be having 40 to 70 macros, but few designs even may have 10, 7 macros. Few designs may have what 250, 300 macros. So the count will vary only from 10 to 300. But how many standard cells you will be having? In the netlist, how many standard cells you will be having? It will be in lakhs. But macros are just in hundreds. So first we'll do what? Macro placement. Place the macros. See, macro placement is not straightforward. It's not that take the macro and place wherever you want. You have to do lot of analysis and you have to follow lot of rules. There are well-defined rules to do the macro placement. So we have to learn what are these rules, how to do the macro placement. So that is covered in advanced part. Right? So next, after the macro placement, we have power planning. See, macros are placed first because they are less in count. Right? See, if your standard cells, if I tell standard cells occupy means what will do? The standard cell will occupy all the regions, right? Because they are more in count. Then I may not get. First thing is standard cells are smaller in size. Macros are bigger in size because it's a big design. So if I tell, okay, I have not done the macro placement, I will do the standard cell placement first. My standard cells will occupy like this. Then where is a, you imagine I don't have macro placement now. Then where is a place for macro placement? Where I can place? Because they have occupied all over the design, right? So now first I will reserve the place for macros. Okay, macros you place here. Then if I tell standard cells to occupy means they will occupy in these regions, remaining regions. They will not overlap on what? Macros. So first we will reserve the place for bigger designs. Then we will ask the standard cells to be placed because macros are less in count and they are big designs. So next we'll do what? Power planning. Why it is required? See, every layout of cells which I am going to place in future, I have not yet placed the cells, but I am going to place the cells in future. Future means what stage? Placement stage. All the cells are placed. So while after placing the layout of cells, this layout of cells required what connection? VDD and VSS connection. See, this is VDD and VSS rail present inside my layout. This VDD and VSS should be connecting to external VDD and VSS, right? The connection should come and connect to what? VDD and VSS of my cells. Yes or no? All standard cells require VDD and VSS connection. So to distribute this all VDD and VSS connections to all the standard cells, which I'm going to place in my design right here. Here I'm going to place all the standard cells, and this each standard cell now requires what connection? VDD and VSS connection. So this is VDD rail, this VSS rail. Now you imagine this VDD is very far. This is a VDD port. You imagine my VDD connection is coming from here. And I have one more standard cell here. This VDD connection is coming from here. Whether you will see any problem in this? See here VDD is 1.5 volt. Generally we will not use VDD as 5 volts or 2.5 volts. What you learn in your UG classes. At the lower technology, when we go to 28 nanometer or 7 nanometer technology, VDD is like 1.5 volts or 2 volts. It's not 5 volts or 2.5 volt. My VDD assume it is 1.5 volt at the port. So when the current is flowing into this metal layer, what is this? How do you make connection? What is this? This is a metal layer, right? When current is flowing through a metal layer, this metal layer also has resistance. When this current is flowing through metal layer and is also having resistance, according to Ohm's law, R into I is going to result in what? Voltage drop V. This metal layer is having resistance and current is flowing. The resistance increases with increase in the metal layer length. If I have more length, I have what? More resistance. If I have more resistance, I have what? More voltage drop. So out of 1.5 volts voltage drop, 0.5 volts will drop on the metal layer itself. So voltage drop on the metal layer will convert to what? It will convert to heat. Voltage drop on the metal layers will convert to heat. Voltage drop in the capacitance will convert to what? Electric field. Voltage drop in the coil will convert to what? Magnetic field. But voltage drop on the metal layer will convert to what? Heat. So out of 1.5 volt, 0.5 volt is dropping on metal layer because metal layer is having resistance. Remaining 1 volt will reach to my cell. Actually, how much it has to reach? If I have 1.5 here, 1.5 volts only should reach here, right? But how much is reaching to my cell? Output out of 1.5, 0.5 is already lost on metal layer. How much is reaching? Only 1 volt is reaching. So because of this, this cell will see huge delay. If I have less VDD, I will see what? Huge delay. This cell will see huge delay. I will see setup violation. I will start seeing timing violations. So to avoid this, this is called as IR drop. We call this as what? IR drop. IR drop is nothing but voltage drop on the metal layer. It's going to convert in form of heat. So to avoid this IR drop, what we do? We do the power planning. So power planning we do for two purposes. One is, what is the reason? To supply power and ground connection for all cells. First thing. Second thing, to reduce IR drop. So I have to gently plan my power planning. How to distribute power and ground for all the 25 lakh cells, and how to reduce the IR drop. I have to do the power planning. After making power planning ready, then I'll go with what? Placement. So what is placement? Place all standard cells in core area. So what are the standard cells you have, right? In your design, you'll start placing inside core area like this. All 25 lakh cells you will place inside your core area. That is called as placement. So what you are placing here? What is this box indicator? It is layout of standard cells. See, I cannot place this randomly. My tool cannot place this randomly. My tool should analyze the connections. See, for example, you see here, this AND gate, U1 AND gate is having connection to what? U2 OR gate. So the layout of AND gate and the layout of OR gate, this is U1 AND gate, this is U2 OR gate. Both should be near to each other because they are having what? Connections. I cannot place very far like this, right? This is U1 and this cannot be U2. If that is the case, I should connect from here to what? From here to here. I should connect. That is not possible. That is becomes very difficult. You will see what is the difficulty in that. You will face congestion. You will see routing issues. Many issues you will feel. It's not so simple as I tell. So place the cells inside the core area. It's not so simple. So my tool should analyze the cells which are having connections to each other. They have to place what? They have to place nearby. So if this is my U1 cell, this should be my what? U2 cell. And this should be my U3 cell. So cells having connection, they should be placed nearby. Only cells are placed, but not yet connected. Just they are placed inside the core area. So we have to do the better placement. So this placement is going to drive my next stages. If this placement is wrong, everything is gone. If macro placement is very important. If macro placement is wrong, everything is gone. In physical design, this plays a very important role, macro placement. Then after that, we have a step called as what? CTS, clock tree synthesis. See, we will build the clock tree. Clock tree is built using buffers and inverters. Whether this clock tree is going to affect the connection of all the cells? I have 25 lakh cells, right? Whether it's going to affect the connection of all the cells? Why it will affect, right? See, clock tree means it is going to affect only the cell which is having clock pin. Which cell is having clock pin? Whether AND gate is having clock pin, NOR gate is having clock pin, then which cell is having clock pin? Flip-flop is having clock pin. So only it is going to affect the connections of what? Flip-flops. So why we have to build the clock tree? What is the necessary for building clock tree? For example, you assume that I have few flip-flops here. This is one flip-flop. These are the flip-flops I have in my design. So how many flip-flops generally I will be having in my design? Minimum 2 lakhs flip-flops I will be having in my design. Out of 20 lakhs, at least I will be having 2 lakhs flip-flops. I have one clock port. This is the clock port. From this clock port only clock will go to my design. So this clock port should connect to all the flip-flops, correct? Because all the flip-flops is having clock. It should connect to all the flip-flops. Then what happens to the load on this clock port? Load becomes very high. Load means, what is the meaning of load? See, every input pin will be having the pin capacitance. You can see the input here. What is the input? Input is a gate, right? Input means what? It is a gate. Gate, below you have what? Silicon dioxide. Below silicon dioxide you have a channel. Gate is positively charged. Below you have silicon dioxide. Here you have channel which is negatively charged. This is going to act like a parallel plate capacitor. Small parallel plate capacitor is formed. We are not going to form it because of the nature it is formed. Nature of the materials it is formed. So this capacitance is called as pin capacitance. What is called as pin capacitance? So every input of every cell is having what? Input of every cell is having pin capacitance. So this pin capacitance is going to form the load for your clock port. Means this flip-flop pin capacitance, this flip-flop pin capacitance, this flip-flop pin capacitance, sum of all the pin capacitance will become the load capacitance for your clock port. So for example, each flip-flop is having pin capacitance of 1 Fermi-farad and I have 1000 flip-flops. Then what is the load capacitance here? 1000 Fermi-farad. Sum of all the pin capacitance. Then what is a clock? This is clock, right? Clock means what? Rise, and this ideal clock, but real clock will rise and real clock will what? Fall like this. Why there is a rise and fall like this? If this capacitance is completely charged, then there you will see what? Rise. If this capacitance is completely discharged, then you will see what? Fall. So as this only one port is connecting to all these flip-flops and the load has become very high, my charging time increases because I have more load, right? Your tank is very big. What happens? You will take more time to fill the water. Similarly, if this capacitance load is very high, you will take more time to charge. Charge means your rise time increases like this. After that, immediately you will get what? Fall signal. So your fall time, then square waveform is converted to what waveform? Triangular waveform. Why it has converted like this? Because huge load on clock port. Only one clock port is driving all the flip-flops. So don't supply the clock through only one clock port. Then start what? You start building your clock tree. Now start building the clock tree. So how do you build clock tree? Now through this buffer, through this port, connect two buffers. So I'll read out this diagram here. You have a port and you have flip-flops distributed. Okay, these are the flip-flops. Now what you do from the port, first use two buffers. Now what is the load on this clock port? Load on this clock port is only pin capacitance of what? Two buffers. Now load on this clock port is only, okay, this part of design is not writing. Okay, load on this clock port is only how much? 2 Fermi farad. So in previous case it is how much? 100,000 Fermi farad. Now it is only 2 Fermi farad because this clock port is driving only what? Only two buffers, two cells. So this pin capacitance and this pin capacitance will become load for what? This clock port. So what is the load now? 2 Fermi farad. Now my clock will easily charge and it will easily discharge. And this buffer will connect to this flip-flop. It will connect to this flip-flop. Again, I cannot connect from here to this flip-flop because the length increases. Length increases means here the capacitance starts increasing. If the net length increases, capacitance increases. I cannot have the bigger length. So to reduce the length, what I will do again, I will be having a buffer used. Use a buffer, connect to this flip-flop, and this buffer you connect here. Again, use one more buffer here, one more buffer you use here, and connect to this flip-flop. So one more connect to this flip-flop. Use one more buffer, connect to what? This flip-flop. So now I am distributing the clock to all the flip-flops by using what? In between I am building through use by building by buffers. So why I cannot connect directly from here to here? Why cannot directly connect here? Output of this buffer I can directly connect to the clock pin of this flip-flop, right? Why I cannot directly connect? Because of what? More net length. This more net length will again create what? More load on this buffer. If it is having more load, again output of this buffer will take what? More time to charge and more time to what? Discharge. So even net length is very important. Net length should not be very high. To reduce the net length, what we do? Again start using building the tree by inserting what? Buffer. So building the clock tree like this by inserting buffers in between is called as what? CTS. So clock tree is mainly built to reduce the load on what? Load on the clock port. So now this clock port is seeing how much load? It is seeing only load of what? Two buffers. And this buffer C is seeing load of how much? Load means pin capacitance of this flip-flop, pin capacitance of this buffer, pin capacitance of this buffer. This buffer is seeing load how much? Only pin capacitance of this buffer. This buffer is seeing how much load? Pin capacitance of this flip-flop, pin capacitance of this flip-flop, pin capacitance of this buffer. So one cell is seeing at least hardly one cell is driving. This cell is driving hardly one cell and two cell and three cell. Only one cell is connecting to three cells or two cells. Earlier, one port was connecting to how many flip-flops? Thousands of flip-flops. So that load we have reduced. As a faculty can teach 60 students or 70 students. They cannot teach to 500 students. For that reason only, to reduce the load on faculty, they have made different classrooms. Right? So next is what? Next step is routing. Routing indicates what? Whatever connections you are seeing here in the netlist, your AND gate output should connect to what? OR gate input. So that connection is not yet happened in the layout. So connect that through metal layer. Right? Connected through metal layers. So last step is connect the cells, macros, and ports. Right? Connect the macros, cells, and ports by using what? By using metal layers. That is called as what? That is called as routing. Connect cells, macros and ports using metal layers. It is called as what? Routing. So while routing, you should see that you are not going to create the short. Short means what? So one cell, both cells are routed here, and this connection cannot run here. My intention is to connect this cell and this cell. I cannot run the same metal layer here. Both get what? Both get shorted here. Correct? Both the connections are shorted. So connect the metal layers in such a way that they are not shorting in between. So do the routing. After routing, we do sign off checks. Sign off checks means final checks after the layout is done. So what are the checks we have to do? See, mainly we do 3 checks. One is power and IR drop check. That is called as power sign off. Means how much power your design is consuming, whether there is any chance of reducing the power. So what is IR drop? I told what is IR drop, right? Drop on the metal layer. Whatever VDD present here 1.5 volt, the same VDD has to reach to what? To the cells. 1.5 volt VDD should not reduce here to 1 volt. So what is your IR drop happening? So all those checks you will do, that is called as power and IR drop check. So next check you will do STA, static timing analysis. So static timing analysis we cover like setup, check, hold check. Latency. What do you mean by latency? Skew, jitter, next we will cover into reg and or I can tell SPA on different SPA on different paths. So next is multi-cycle path. Off cycle path. So next we cover asynchronous timing. The SPA is applicable only for synchronous designs. It is not applicable for asynchronous designs. So how to handle asynchronous designs? So like reset, if you have reset, what is recovery and removal checks? So all those things we see in STA. So next, last, one more check is physical verification. So physical verification again, it deals with the DRC. Whether we are foundry rules. I told you foundry is giving the rules, right? Whether we are meeting that rules or not. So next we'll check LVSL, layout versus schematic. So what is layout here? This is my layout. What is schematic here? I don't have any schematic. Schematic means it is my netlist. What is schematic here? Schematic is my netlist. Whether connections present in the netlist, whether I have same connections in the layout or not. So in the netlist, what is connecting here? Output of AND gate is connecting to what? Input of OR gate. Whether the same connection is present in the layout or not. We cross verify that. That is called as layout versus schematic. Here layout is, this is layout. What is schematic? Schematic is your netlist. Comparing both is called as what? Layout versus schematic. So then we'll do base level DRC check. Base level DRC means DRC check on polysilicon, diffusion, N-well, and your P substrate. All these are called as base layers. So base layers, we are going to do DRC check. So these are the different sign of checks we do in physical design. So we use different tools for different purpose. Same tool is not used. For synthesis, we use a tool called as DC shell. EDA tools. What EDA tools we are using? Electronic design EDA tools. So we cover even synthesis as part of our syllabus. So we use a DC shell, design compiler shell. DC stands for design compiler. So for physical design, the tool used is ICC2. In industry, two tools are very famous. One tool is from Cadence, one tool is from Synopsys. So we are using Synopsys tools. What is the Cadence equivalent for DC shell? It's Genus. Genus is from Cadence. But we are using what? DC shell. This is from Synopsys. So industry uses either from Synopsys or from Cadence. We are using Synopsys. So few industries may use even Genus. So for physical design, we use ICC2. What is the equivalent version in Cadence? It is Innovus. Equivalent version is Innovus. This is from Cadence. This is from ICC2 is from Synopsys. We use ICC2. ICC2, but industry uses FC. FC means Fusion Compiler. Fusion Compiler and ICC2 both are same. Means Fusion Compiler has more license like DC shell, this ICC2, and all the sign of checks. They come in single bundle. That is called as what? Fusion Compiler. But if we use separately, then this is called as what? DC shell. This is called as what? ICC2. So ICC2 and Fusion Compiler both are same. There is no difference even in command also. Both are same. Don't get confused. Industry is using Fusion Compiler and Institute is telling ICC2. So Fusion Compiler and ICC2 both are same. Even command, single command also same. Both are using same command. This will come with complete license. All the license is in single bundle, like license for your synthesis, license for your physical design is in single bundle, but we have separate license because companies has huge investment, they will invest, but we cannot do that. These tools are not simple to purchase. Tools are very costly, like they are 30 lakhs for 20 users. You have to pay. They are not very easy to purchase. Even they are not readily available in market, like your Xilinx. We can download free source. So we cannot do that here. And for sign off checks, so power and IR drop, we use Redoc. So STA we use RRC for RC extraction, and we use prime time. RRC and prime time we use for STA. For physical verification, we use IC validator. So what is the syllabus covered? So the same syllabus, right? We cover synthesis completely. Then we cover what? All the steps of floor plan, including STA. Even we cover multi-voltage design. So I have not mentioned here multi-voltage design. We'll also cover this. Multi-voltage is optional. Every design is not multi-voltage. Very few designs are multi-voltage. Multi-voltage design is a power reducing technique. See, we use Linux operating system. You need not to worry. Your laptop is having Windows. You are not going to work on your laptop. You are going to connect to our servers by using your laptop. By using your laptop, you will connect to VLSI Guru servers. You will work with that. How to connect to servers, everything will teach you. Only you should be having the laptop and with Windows operating system. That's it. And good, if you're working from home or if you're attending online, you should be having good internet. And if you're coming to institute, no issues. We will provide you the internet facility. Nothing, right? Any configuration of laptop. See, you are going to work on our server. Your laptop should turn on and you should be able to open only two applications. One is 40 client, one is 40. Two application you should open and connect it. That's it. Apart from that, I am not going to tell that your laptop should be of i5 configuration or i7 processor because you are not going to work on your laptop. You are going to work on our servers. Laptop is just a connecting medium. From your laptop, you will connect to our servers. You are going to work on our servers. So our servers should be of good capability. So our servers are good capability. Your laptop, if it is a basic version, also fine. It is no issues. You can use that. Like at least you should be having i3 processor. i3 is a basic processor, right? i3 Intel. Okay. Next, all this syllabus we will cover. So next is our course content. This is the advanced course content. Our course is split into two things. One is basics. Another one is advanced. In advance, we are going to discuss about what? Physical design with industry standard project. Okay. Physical design, all the concepts of physical design. So in the advanced part, what we do is Saturday and Sunday will be theory session only for Saturday and Sunday. And your lab, again, lab is of two category. One category is for weekday students who can come on weekdays and they can work. So this happens from Monday to Thursday. Lab means you will be working on project. This is from Monday to Thursday, every day 3 hours. Even this theory also every day 3 hours, Saturday and Sunday. So lab happens on weekdays from Monday to Thursday, 3 hours. Friday is off. Saturday and Sunday you will be attending what? Theory. Every student has to attend theory. Lab is optional. You can attend on weekdays or you can attend on weekend. It is optional to you. Weekend lab happens only on Saturday and Sunday. You can either attend weekdays classes or you can attend on what? Weekend classes only for lab. Theory is common for everyone. If you are opting for weekend, first you will be having theory, then you will be having what? Lab. So weekday students will need not to attend weekend lab. They can attend only from Monday to Thursday. See, this weekend lab is planned only for the students who are not able to come on weekdays because some of the persons will be working. They will be doing this course on only on weekends. For them, they can attend the theory in the morning and afternoon they can attend the lab. Other students can attend the lab from Monday to Thursday. This is how the advanced part works. And during the advanced part, the tools are given to you. So you can tool access is 24/7. 24/7. You can access the tool. You can use anytime you want because our servers are on 24/7. So you can use the tool 24/7. but you are working on our servers. You are not working on your laptop, and our servers are on by 24/7. You can work on anytime you want. So you can use our tools. So tool will be given only when your advanced course starts. So advanced will be for 3 to 3.5 months. General it is 3 months. Some batch it may extend to 3.5 months. 15 days may get extended because of Diwali holidays, Dasra holidays. Means 3 days, 1 day holiday, 2 days holidays also it will get extended. All right. In between, mentor is not feeling well. So it will happen for 3 days to 3.5 months. So this entire 3 months plus additional 1 month, 3 plus 1 month, you can access the tool. When advanced course starts, you can access the tool for entire 3 months during your course time. So when your course completes, after that extra 1 month we will give for practicing from the day of the course completed. It is not only 3 months. Your course may complete even after 15 days also. It will take 3 months, 15 days, 3.5 months. So from the day of course completion, we will give 1 month extra. So you will be accessing your tool for 4 months. After that, we'll remove the access. We will remove the access for the candidates who are working from home. If you want to use a tool, you can come and use in the institute for next 1 year. The institute you can work here, you can use anytime. We will remove only VPN connection. But if you come to the institute, you are in the institute network. You can use a tool anytime. But when you are working from home, because tool is very costly, what students will do, they will give the tool for some other person, like industry persons to practice. When we extend the tool licenses, because they have learned they don't have anything to work in tool, they will. Some students we have also seen like this, right? You are also selling the tools. We have also seen that. So we will give tool for 4 months. So utilize it properly for your things. So basics is on weekdays. There is no weekend basics. It is from Monday to Saturday, all the days. Sunday is off. But when we come to advance, when it is off is on Friday. Basics off is on Sunday. So if you cannot attend weekdays basics, please contact admin. Is there any provision for to attend basics on weekends? So if you are not able to attend any classes, see the mode of class is both online and offline. You can attend either offline, you can come to the institute, or you can attend online also, like how it is happening right now. I am doing offline plus online. Few students are attending online, few are even attending offline. The same way, the mode of class will be both offline and online. You can attend whatever mode you want, and the same placement and same facility will be there for both. There is no change in the facilities. First thing. Second thing, video access is given. So timings, I am not sure. I cannot tell the timings. Admin will tell you. See, video access is given to all students. See, this video access is not the pre-recorded videos, current live session running videos. For example, today I have taken a session of digital. That will be recorded. Same how I am recording, it will be recorded, and that video will be given after 4 hours when the class completes, because they need a time for uploading. Because the video will be in GB, they need time for uploading. It will take 4 hours to upload to the portal. So they will give you the access, video access, live video access. If you miss the class today, morning 10 o'clock to 1 o'clock, you are not able to attend the class, you can see the video in the night. After 4 hours, you will get the video. You can use the videos. So video access is recorded, video access is given. You will get 2 videos. One is pre-recorded videos. One is live recorded videos. Both videos will be there. Pre-recorded will be some other batch. Live recorded video will be your batch. Both will be given to you. Compulsory live recorded video is given. If you miss the class, you can see the video in the night, but don't cultivate that habit. Right? I am seeing the students not at all attending. They will see only videos and they will practice. That is up to you again. See, changing the mode is left to you. Whenever you feel you can attend online, whenever you feel you can come to the offline. Anything you can do. Today you can do online, tomorrow you can come offline. Mode of attending the classes is left to you. You can come offline. Mentor is available in the institute. The same way how I am taking the class now, offline and online, both I am taking. The same way it is taken. So you can use whatever mode you want. And you can change the mode also. You can attend whenever you want. You can attend the online. Whenever you want, you can attend the offline. It's up to you people. So, and video, if you miss the classes, video access is given to you people. So basics, what is covered? So we will cover digital. So digital is nowhere used for physical design, but at least you should be knowing what is mux. So you should be knowing. Yes, I'll come to project later. Right? You should be knowing at least what is mux, what is flip flop, what is latch, what is difference between latch and flip flop. At least these basics you should be knowing. And digital we will never use in our physical design, most of the concepts. But in interview they will ask what? Digital. So if you even answer the advanced part and if you're not answering the basic part, your interview will not be cleared. Basics is important. So if they ask the question, what is the full form of FPGA? Field programmable gate array. What is MOSFET? Metal oxide semiconductor FET, field effect transistor. You have field in that, you have field in this. What is the difference between that? Field programmable gate array. Metal oxide semiconductor field effect transistor. So what is field in that? What is field in this? Okay, at least I have went one step ahead. Few students will not answer what is the full form of MOSFET itself. So when you answer even physical design concept, but if you're not able to answer the basic question, all right, then you cannot clear the interview. So basics are very important. So you should be knowing digital basics. So then means I can tell in this basic classes this digital is covered. Right? Then Unix is covered. What is Unix? I told you these whatever tools we are using, all the tools will be used in an operating system called as Linux operating system. So Linux has their own commands. See how to create a file here. Right click, new folder. But in your Unix, you have a command for that. To create a folder, you have a command. So you are going to learn Unix commands. How to copy file from one location to another location. How do you copy here? Right click, copy and go and paste wherever you want. That you will do by using graphical user interface. But how to do? By using commands. So that you will see in what? Unix basics. Then you will learn about TCL, tool command language. TCL means it is a programming language, that is tool command language. All these tools, whatever I specified, like your ICC2, Innovus, or even your DC Shell or Genus, all these tools can understand only TCL. So you should be knowing tool command language. Then we cover CMOS basics. In CMOS, we cover what is semiconductor, what is PMOS, what is NMOS, what is CMOS, what are different CMOS circuits, what is layout, what is fabrication steps. So all these things we cover in CMOS. And we just cover some PD basics, like what are the inputs for PD, what is synthesis, some basics. Even that is covered in advance also. Just we will brush up some small things. So these are the content of your basics. It is not compulsory that you should opt for basics. If you want basics, you should opt. If you're not good in all this concept, you should opt for basics. Right? So this is what the things is. This is what the course content is. So if you opt for basics, the basics will go for 2 months. All this basics will go for 2 months, and your advance is for 3 months. Approximately it will take 5 to 5.5 months. Entire course, including basics. Right? Then what are your queries here? Online, I have answered. How many projects will be done? So 2 projects will be done in advance. Here we do 2 projects. One project is done with help of mentor. So mentor will guide each and every step. Floor plan, this is a command. So mentor will do, you will also do parallelly. So one project you will do with help of what? Mentor. In presence of mentor. One project you should do. After doing one project, second project you should do it. So most of the students will not do it because they will get the job even doing the second project, or few will refresh the same concept, because doing the project is not important. Answering in interview is important, right? Shared recorded videos is not for lifetime. Live recorded videos will be available only for 15 days. From today, if I do the videos, they will give you the video. That video is available for next 15 days. After 15 days, that video is removed. This video is given only for, the thing is, if you miss the class, you should be able to recover the concept or refresh the concept. Or in the class, for some reasons you are not able to understand. Again, you can see those videos. Or if you miss the class for some reasons, because it is uncertain, right? Students may miss the class because of some reasons, like some function or some things. Then you can recover the concept, or you can refresh the concept. For that reason, the videos are given. So one video, if you upload today, that video is available only for next 15 days. The second video what we apply, that is available for next 15 days. It's available only for 15 days. Live recorded videos. But pre-recorded videos are available till the course completes. Pre-recorded videos means we have made few set of videos which are excellent videos. Okay, I have answered that question. So I have told what is the course duration. It is for. Okay, what about placement? So first I'll tell you how the placement works. Right? There are product-based companies. What are product-based companies? The companies which are they get IC fabricated. So what are the examples for that? Intel, AMD, Qualcomm, Nvidia, MediaTek, Samsung, ARM. They are product-based companies. So product-based companies will not hire any candidates directly. They will hire only 3+ or 4+ years experience candidate. So Intel, Qualcomm, they will not hire freshers. They will hire only, because none of the product-based companies will invest their time in training. Even though they have training material, they not invest. They will not invest. So what they will do is, they will hire only 3 or 4 years experience candidates. Product-based companies. And product-based companies will also hire candidates for internship only from reputed colleges like NITs, IITs. They will hire it. But there are product-based companies, especially physical design. Only 20% of work will be done in product-based companies. Remaining 80% of work will be sourced to service-based companies, especially physical design. Front end, it is different, right? So 80% of work is given to service-based companies. Service-based, you will be employee of service-based company. For example, you are employee of some company name, you call it as VLSI Guru only. This is VLSI Guru is employee. It is a service-based company. So VLSI Guru will hire you, and VLSI Guru will ask you to work for the project of what? Product-based company. Either you will go to Intel or Qualcomm, or you will go to AMD and you will work. You will go to that location only, you will work, or the entire project they will get to their company only, and you will work in VLSI Guru only. So if they get entire project, that is called as ODC project. Complete project is given to VLSI Guru. So VLSI Guru will hire the employees and they will ask to work on their project. But this project is not a project of VLSI Guru. It is a project of what? Some product-based companies. I am using the word VLSI Guru just for a reference, service-based company name, right? So you will be easy to get in what? Service-based companies, not directly into product-based companies. So service-based companies, now physical design placement is excellent, I can tell. So there is more projects running. So the placement of physical design right now is excellent. We have excellent placement running. See, past 1 year or almost 1 year before, we see huge recession. But now the situation is not like that. Now there is a more demand for engineers. So service-based companies will hire you. They will do some training for 1 or 2 months, and they will put you on the projects of product-based companies. So now the placement is very good, right? So I can assure you that. See, you don't ask me what are the companies coming, because I cannot remember all the company names. So I am the part of the training, or I am the part of the trainer, and I will not be knowing the office. Means I cannot remember all the companies. I know few companies which are coming to VLSI Guru. So you can contact. You are if you are joining, you will be created a WhatsApp group. In that you can ask what are the details you want. See, there are many service-based companies. Whenever they need a candidates, they approach us. When they approach us, we will shortlist the resumes. We will be having internal assessment. We will not give the resumes whoever enrolling for the courses. I'm telling you at the beginning only. We will shortlist the candidates based on our assessment. Because, for example, one company come to us for placement, and if I give the person who is not prepared well, and if we lose the image there, if that company feels that all the candidates from VLSI Guru are of waste, means we will lose our reputation, and it is going to affect the placement of remaining candidates. So what we do is we do the assessment, regular assessment we do. We conduct tests, we give assignments, we do mock interviews. After doing this assessment, who are performing well, the resumes we shortlist and we'll give to the companies. So that is what the thing. See, the packages vary from company to company. I cannot tell this is a package. See, initially company may pay you 15,000 per month for 1 month or 2 months, because you are not yet working in the client project, because the company is training you. It is just for 1 month. Most few candidates, even they get placed in, even for example, VLSI Guru is hiring you. Assume that VLSI Guru is a service-based company. We hire you, and I will not get any single rupee benefit from you. I have to simply give you the salary. I will get benefit from you only when you work on what? Client project or product-based company project. So you have to clear the product-based company interview. They will keep on interview. Product-based companies will not give you the project to you simply. They will keep on interview. Small questions will be asked to you. As soon as you clear that interview, when you start working in the product-based companies project, your salary will be approximately around 40 to 60,000 starting salary. It depends upon company again. I cannot tell this is the package. Starting salary will be around 40 to 60,000 when you start working as a client project. So that depends upon your ability. Some of the candidates have cleared the interviews within 15 days. Some of the candidates will take 6 months to clear the interview. That depends upon how you take the course seriously, how you learn the content. See, I cannot answer this question where I can see after 10 to 15 years, because myself, I am not experienced than 10 years. I have 8 or 7 years of experience, but I can tell you only one thing. It depends upon the learning ability. See, first you will be working on block level design. This is a block level design. when you work as a block level design, after 3 years, they will ask you the questions of this IR drop. Right? You cannot tell that I don't know what is IR drop. Means after 3 years of working, what you have learned in the working phase. So you can, okay, you are telling that I know IR drop, I know STA, I know physical verification very good, I know PD very good, I know synthesis very good. Then you are capable of becoming the lead. Within 4 years, if you know all this concept very good, and you work, see, knowing is different and working is different. If you worked in all these domains, you can easily become what? Lead for 5 candidates. Means you are responsible for guiding them. Do this, like this. So when you become the lead like this, your salary is different. Even after 4 years, you are the person who is not a lead, and you are just working on the same design, a small design which is given to you, do the physical design, the same thing you are doing, then you will be in the lower end of salary. So if you want to be at a higher end, you should learn what? Many things as you work. So then you can get the higher salary. So the person who is working, see, within 3 years, you can claim a salary of 1.2 lakhs per month, like 1,20,000 per month. You can claim that salary when you become experience of 1.5 year or 2 years. You can claim that salary, right? That is what I can tell. And growing, it is left to you. How good you grow, that much good salary you will get. That you should grow. It depends upon the growth. What is the next question? That is a package, right? The package also I have told what is the package will be. Fee structure. Fee structure, I don't know. Please contact the institute. Fees, what is the fees? Almost it will be like 55, 57 to 60,000. It is almost. You contact the institute about that. Institute will, our, if you message in the WhatsApp group, right? They will respond with the fee structure. Mock interview starts within the first month or after the completion. So mock interview happens stage by stage. First we do digital. After that there will be, we cannot conduct the mock interview for digital. We will conduct the test. We will do CMOS. We will conduct the test. We will do TCL. We conduct the test. We do Unix. We will conduct the test. After completing entire basics, we conduct mock interview. Right. So we cannot conduct mock interview every day or every month. It is stage by stage. Right? We conduct mock interviews. So during advanced part, we will conduct mock interviews at least twice. Each candidate will be conducted once is for sure after completing the course. One mock interview is for sure. In between, we'll conduct somewhere in between, like after floor plan or after CTS. Somewhere in between, once we'll conduct the mock interview. See, mock interview is not like that. If you don't clear, we are not going to consider for placement. If you don't clear, again you can take up the mock interview when you are prepared. Every student will be created with WhatsApp group, individual WhatsApp group. In that WhatsApp group, you will be there. Our office staff will be there, right? And mentor will be there. So if you are prepared for mock interview, you can put in that individual WhatsApp group that I am prepared for mock interview. Please tell me the timings when I can take the mock interview. So our office staff will see this message. Based on the availability of the expert, they will allot the mock interview timings. If you don't clear today, for some reasons, our expert will tell where you are lagging also. Mock interview is not done to filter you people. Mock interview is done to make people ready, because we cannot give the candidates who are not ready to the interviewers. Our expert will tell where you are lagging. So you can learn, you can revise those concepts. Within 1 week, if you are prepared, again you can message in that group. Again, I'm ready for mock interview for second time. When can I take my mock interview? Again, if based on the availability, within 1 or 2 days, our office staff will schedule the mock interview. Again, you can take the mock interview. You can take mock interview n number of times you want. It's not that once if you are not doing well, you are not selected. You can take mock interview till you get the job. Certification also, right? The same mock interview test, everything, right? The student who is joining today, after 6 months, he is not at all visible, and 7th month he will come and ask for the certificate. We cannot give that because what happens is he will tell that I am the person from VLSI Guru, and in the interview, if he is not answering, the reputation of institute will go. That company will not come for a placement again for us. So only one criteria is to give the certificate is just clear the mock interview. The mock interview will not be having any questions which you don't know. It will be having the basic questions like explain the input files for physical design, explain the flow in physical design, explain the methods to fix congestion, which we've already covered. That only we expect from the students to answer it. That's it. See, we are going to give ICC2 tool, which I have already told you. We are going to use ICC2 tool for physical design. Innovus is not used. Getting one license only is of huge cost. Right? We cannot get both licenses. See, tool is just a matter of using it. It is very easy to use the tool in industry. Industry is automated. You need not to worry about that. Knowing the concept, cadence or synopsis, the flow remains same. After floor plan only you should do what? Placement. Flow remains same. Concept remains same. Only using the tool varies. Obviously, both are different because I have worked on both the tools. CAD Innovus and ICC2, both have different commands. Commands are different. Working model is also different. That has different model is a different model. But working on tool is not very difficult because along with the tool, they will give you the user guide like your manual. Lab, you have manual, right? There will be user guide. By seeing user guide, you can learn any tool. But you should be knowing the concept. No, don't. If you're mechanical engineer, better don't opt it because part-based companies will go for background verification. They may not hire the mechanical engineers. But if you have the assurance of any company telling that you can join even you are from the mechanical background, then you can join. But we cannot give the assurance because company will scrutinize. Right? They will see you should be from electronics or electrical background or computer science also okay. But mechanical, I think it is. If you are giving anyone, any other person is giving the assurance that we are going to hire you, then you can join, right? Or else I suggest don't join. See, we have course for analog layout. We don't have course for analog circuit. We have course for analog layout. I don't know when the course is starting. You can contact the admin for that. Krishna, that is mechanical. I've answered, right? What is a class tensor? See, we have the licenses, 30 licenses at a time. So we cannot have more than 30 students at a time, right? Basics, I can have 60 students at a time. I don't have any problem. But for advanced physical design, hardly 30 or max to max 35 students in a batch for advanced courses. For basics, it can be till 60 per batch. Batch means I am telling you at a time we cannot take a class for more than 35 students in advance because the license what we have is limited. So I cannot ask 60 students to work together because we have limited license. So one student may be getting license, other student may not get the license. If we ask all the 60 students to work together, then what we do is we will split the entire batch into two batches. One batch is of 35, another batch is of 35. One batch will work in the morning, one batch will work in the afternoon. See, functional verification, you have to deal with Verilog, system Verilog. It is more of programming and understanding the protocols. For example, if you have protocols like Ethernet, Ethernet has some protocol, how to implement the Ethernet thing, right? You have some protocols. You have to understand the first Ethernet architecture and protocols. Based on that, you should be understanding how to write the functional verification code to test that Ethernet module, right? So it is full of coding. I can tell Verilog coding or system Verilog coding, functional verification. Physical design is not full of coding. It is just understanding the issues and fixing it. How to understand the issues. If you get congestion issue, how to address the congestion. If you have the DRC issues, how to address the DRC. After the routing stage, you are seeing 50,000 shots. Shots means one metal layer, another metal layer, they're shorting each other. So if you see that much shots after routing stage, how to address that issue? What is the method to fix it? So understanding the concept and understanding the method to fix is done in physical design. But front end is full of coding. You have to write the Verilog codes pages together. Yes, see, company only will put you the experience. If you are a candidate of 2021 passed out, service-based company will hire you. They will put you 3 years experience. They will give you the salary of 2-3 years experience only. They only will take the advantage of that. If you have year gap in between. So the person who is passed out and person who is passed out in previous years, who is having better advantage? Person who is passed out in 2021 or 2022, he is having better advantage because service based company only will put you the experience and they will project you as experienced candidate to the product based companies. That is what the service based companies will do. For example, I am passed out in 2018. I have done the course and I will attend the interview. Service based company, what they will do? Okay, 2018, 19, 20, 21, 22. Okay, I will put 4 years experience on you. And they will train me to the level of 4 years experience and they will send me to the project of Intel telling that 4 years experience because Intel will pay more salary for 4 years experience guy than what 3 years experience then guy, right? So if you have year gap, that is advantage, especially in VLSI, because product based companies will see you have experience. So service based company is going to put the experience on you. They will put the experience on you. So to put the experience on you, you should be having year gap. And I'm not telling that fresher is not having advantage. Fresher can also work on the projects because I told you, right, there are two types of a project. One is you go and work to the client location. You go and work in the Intel office. You go and work in the Qualcomm office. You are a employee of service based company and you are the temporary employee of those product based companies. Now you will go to the Qualcomm office and you will work till the project is done. In this condition, you need experience. But entire project comes to your service based company. Entire project, for example, entire project from Qualcomm comes to Capgemini. Capgemini can use whatever employees he wants to complete the project. So he will use all the freshers only because freshers are paid less compared to high experienced candidate. So both has advantage here. That is called as ODC project, off the shelf, means entire project is shifted to them. But don't discuss all these things in your outside things. You will get affected, right? If product based company candidates will come to know that this is happening, means you will get affected, right? I am not going to get affected. You will get affected. So I'm telling that both are having advantage. If you're having year gap, service based companies, they themselves will put the experience on you. If you don't having year gap, if you are a fresher, you can work on ODC projects. The company, they themselves will give you they bring the ODC project, then you can work on them. Both are having advantages. Is there any complexity in because every course is having complexity. See, there is nothing called as without complexity. But what I can tell is physical design is with just understanding what is the issue, right? I have more shots. What is the issue? What may be the reason for shots? Once you understand what is the reason, then this you can apply for lifelong. So physical design you will get easy when you become experienced, like little bit experience. If you become easy, you will become experienced. But Verilog content is not like that. You should be good in coding. You should be, if I tell D flip flop, you should be ready to code immediately. If I tell counter, 4-bit counter, you should be ready to write the Verilog program. So it depends, both the skills are important, right? Both the skills varies differently. So whichever you have skills and you can, compared to front end, the physical design is easy. I can tell little bit easy compared to the functional verification, because many will fail to understand the protocols and they will fail to convert that protocols into a program. In that part, it is difficult. But compared to that, physical design is not so much complex. It can be compared to that, it is easy. Physical design is easy. Anyone can work in physical design. It's not that you should be having good knowledge also, because the industry is automated fully. Right? Even front end is also almost automated, because ChatGPT is already there. If you type, give me the TCL program or Verila program for this, ChatGPT will give lines to lines of programs. So everything is automated. None of the domain is difficult now. Everything is easy. No, if you have age gap, if it is within 5 to 6 years or 7 years, okay, no issues. You can work. Age gap is an advantage in VLSI domain. Right? If you have year, means if you have that gap, if you are passed out in 2018, for example, that is advantage, because service-based company will put the experience on you. Because service-based company candidate cannot put the experience on the guy who is passed out at what 2024, because his marks card is telling that he is passed out in 2024, and I cannot tell that he is 3 years experience guy, because he is passed out his 8th sem in 2024. How can he become a 3 years experience guy? He cannot become a 3 years experience guy. So freshers will work on ODC projects. But if you are passed out in 2018, then the service-based company tell that he was my employee for 4 years. They will put the experience. They themselves will put the experience and they'll project you to the projects. But putting experience is good to get the salary. But the same type of talent you should show when you are working in the project also. Right? Same knowledge or talent you should be having. But no issues. When you work here, when you take up this course, you can do it. It's not a very big thing. Yes, any other doubts? Offline, any other doubts? We can get it. I will send this to admin. He will give you. Because I don't have direct contact to you people. Because even I'm not in your group also. So I will forward to admin. Admin will send you. Any doubts? See, class generally starts from Monday itself, tomorrow itself, basics. But see, whether there is any contact with you, with the institute, any contact you have, any WhatsApp group is created, and even we have email IDs also. So they will inform you when the class starts. Generally, we start from Monday or we start from Tuesday. Digital will start from Tuesday, but generally we don't start with digital, because we will see few enrollments also after we start with GVM. GVM is nothing but how to use that file editor, text editor. It is a same text editor, but it has few commands. So industry will not use this type of text editor. Industry uses a text editor called as GVM. So GVM has some commands to use this text editor. So I want to find some word. How to find here? Press Control F, and I want to find what? Floor plan. It's finding, right? But the same operation you can do in GVM by using command. So what is the command for that? So file has some commands to use it. So how to use that? So that I think they may do at the beginning. Again, they will do once again later. But at the beginning, they will do this because our enrollment is not free still. Students may join even after 2 days. So within after 2 days, from Wednesday or Thursday, your digital will start. But your course will start from Tuesday itself, I think, or Monday, tomorrow itself. That will start. Our admin will inform you, or our team will inform you in WhatsApp group or either in through mail. They'll inform, because I am not sure when it is starting. And we are seeing more enrollment also. So these many students we cannot put in the same class, because we are seeing almost 90 students have filled the form. So 90 students we cannot conduct the classes at the same time. So we have to split them into batches. So our admin, our office staff will inform you about the classes. So it will start from tomorrow or from day after tomorrow. But don't worry, if you're not able to attend within tomorrow, day after tomorrow, you can attend from Wednesday also, because I told you they will start with GVM. It is just a file editor command that you can learn even later on. Self-paced means it is only online mode, even that is also available. Online course is also available, means online means only you can learn through videos. This is also available. You contact the admin will inform you how to proceed with this. Self-paced course means it is just a recorded video course is also available, or you can also take up the online course. Online means, yes, only two. Physical design project means it will take 6 months to complete. One project means it has to go through all these steps, right? From floor plan to end. To do one project only, industry will take 1.5 years. So we will complete within 5 months. So we can do only two projects. It's not a project, means it's not like a very small project. Right? It is one project will go through all these steps. What are the steps? Floor plan, placement, CTS. It is not just placement will complete in one day. It will take at least 2 weeks to complete. Because I have to do explain placement, steps in placement, commands to do placement, what are the issues in placement, how to fix the issues. All those things should be discussed, right? So that will take 5 months to do all these things in the course. Each step. When I come to CTS, course I've already told, it is like advance is for 3 months, basics is for 2 months. If you skip basics, it is only for 3 months. Yes, coding we have, but not lot of coding we don't have. Only small coding like tool command language. We have TCL, right? We have small coding. Coding is done to make your work automated. See, I have to fix the issues. I have 5,000 issues. The same steps I have to do 5,000 times. Once you do, one issue is fixed. Second time you do, second issue is fixed. Third time you do, third issue is fixed. If you do this for 5,000 times, you cannot do this, right? Then you write a small piece of code that will do the same step repeatedly on different cells. Take first iteration, take first cell, second iteration, take second cell, third iteration, take third cell, do the same steps for different cells. So thereby you are doing automation. You need not to do the same step 5,000 times. So you have small coding. TCL coding you have. Yes. Okay. Thank you, everyone.